this video I'm going to take a look at the Leaving Cert 2019 Maths Paper 2 Higher Level. This is the quick read through video where I have the solutions already done. I'll read through each question and read through my solutions. If you want to see the step-by-step solutions video, I'll put the link to that in the description and in the comments below. So let's get started into question 1. Probability question. A class consists of 12 boys and 8 girls. 2 students are selected at random from the class. What's the probability that the 2 students selected will be a boy and a girl in any order? So this one is a boy followed by a girl plus a girl followed by a boy to get 48 over 95. Part 2, 4 students are selected one at a time at random from the class. What's the probability that the first 3 will be boys and the 4th will be a girl? So this is boy, 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 girl. And remember, we're reducing the denominator each time because the students are not put back in. So 88 over 969. Part B, an examination paper is made up of 2 sections. Section A has 7 questions, Section B has 8 questions. The paper contains the following instruction. From Section A, you must answer question 1 and any 3 other questions. From Section B, you must answer any 4 questions. So how many different combinations can be answered? So we have to do question 1 in Section A, so that's 1 choose 1. Out of the rest of them, we choose 6 out of 3, so 3 out of 6, 6 choose 3, and then Section B is 8 choose 4. Into your calculator, you'll get 1400. Part 2 then, coordinate geometry. The line P makes an intercept on the x-axis at A0 and on the y-axis at 0b, where A and B are not equal to 0. Show that the equation can be written as x over A plus y over b equal to 1. Well, there's several ways you can do this. The way I've chosen is to sub in each point. So sub in A0 and it should get balanced. Sub in 0b and it should get balanced. It does in both cases, so that means the equation can be written as that. The line L has a slope m and contains the point A, which is 6, 0. Write the equation of the line L in terms of m. So y minus y1 equals m times x minus x1. Sub in 6 and 0 and m to get y equal to mx minus 6m. The line L cuts k, which is 4x plus 3y equal to 25 at p. Find the coordinates of p in terms of m and give each coordinate as a fraction in its simplest form. So y is equal to m times x minus 6. This is the one from before. The equation of k is 4x plus 3y equal to 25. We can sub in m times x minus 6 in instead of y. So there it is there. Get x on its own. There's x in terms of m. And then get y on its own and sub in x in here and get y as m over the 3m plus 4. Question 3. The point minus 2k is on the circle x minus 2 squared plus y minus 3 squared equal to 65. Find 2 possible values of k, where k is an element of z, the integers. So we sub in minus 2k into the equation, work it all out, and we get this, get down to k minus 3 is equal to plus or minus root 49, root 49 being 7. So k is 7 plus 3, which is 10, or minus 7 plus 3, which is minus 4. Part B, the circle S is in the first quadrant. It touches both the x-axis and the y-axis. The line T, which is 3x minus 4y plus 6 equal to 0, is a tangent as shown. Find the equation of S. So the center is minus g minus g. We know that it's the same because the radius and it's a tangent to both the y-axis and the x-axis, so we go up and across the same distance, so it's minus g, and the radius is going to be g. The perpendicular distance from minus g to the tangent is the radius, so that's g. So we use the perpendicular distance formula, subbing in everything we know and letting it equal to g. If we work down through the algebra here, we end up getting g is equal to 6 over 4 and g is equal to minus 1. Well, we have a look. If g is 6 over 4, that means the center is minus 6 over 4, 6 over 4. That can't be true because we know it's in the first quadrant. If g is minus 1, that means the center is 1, 1, and the radius is 1. That does work in the first quadrant. So that means our equation is x minus 1 squared plus y minus 1 squared plus 1 is equal to 0. Any questions about the algebra there, just ask in the questions below. Question 4. Show that cos 2 theta is equal to 1 minus 2 sine squared theta. So this is using your identities from the log tables. Cos of a plus b is equal to cos a cos b minus sine a sine b. A is equal to b in this case, so cos of 2a is equal to cos squared a sine squared a. So the cos of 2a is 1 minus sine squared a minus sine squared a, letting cos squared equal to 1 minus sine squared. So that's 1 minus 2 sine squared a as required. Part B, find the cosine of the acute angle between the two diagonals of a cube. For this one, let the side equal to x, any unknown number x. The diagonal of a face then is the square root of x squared plus x squared, which is 2x, or root 2x. So that means we have, this is a face, we have x, and we have the diagonal root 2x. The internal diagonal then, we can use this triangle. So we have a side x, the diagonal root 2x, and find the third side of that triangle. The diagonal is going to be root 3x if you work through Pythagoras again. So now that gives us a triangle where we have side x, side root 3 over 2x, and another side root 3 over 2x with an angle A. This is the angle A that we're looking for. So we can use the cosine rule. Here it is here. Isolate cosine, work through the algebra here, and then we end up, the x's will cancel and it'll all work out to be cosine of A is equal to 1/3. Again, any questions, just ask in the comments below. Question 5. Construct and label the orthocenter of the triangle ABC in the diagram below. To get the orthocenter, what you do is you draw a line that is perpendicular to each side that then goes through the opposite vertex. So this one, perpendicular line going through the vertex. For this, from point C, you can extend this line AB, and still it's going to be a perpendicular line coming from C through this line, and where they intersect, O, that's your orthocenter. Part B, in the diagram below, O is the center of the circle S, and AB is the diameter of S. BE is a tangent to S at point B. BE is a tangent to S. CD is a chord. CD is a half AB, so CD is a half of AB, and is parallel to AB. Find with justification the angle BEA, which is this angle here. So here's the solution for that. The side DC is equal to the side OB, or the length OB, that's given. Therefore DC is also a radius. The triangle ODC therefore is equilateral. That means each angle in it is 60 degrees. That means the angle AOD is also 60 degrees by alternate angles. That means the triangle AOD is isosceles, as OA is equal to OD. They are both radiuses, OA and OD. So the angle OAD is equal to the angle ODA, which is 60. The angle ABE is equal to 90, as BE is a tangent. And that means the angle BEA is 180 minus 90 minus 60, which leaves us with 30. If you're unsure about that, just go through step by step and point at each side, each angle, each triangle as you're going through it, and it should make more sense then. Question 6. Two independent events, F and S, are represented in the Venn diagram shown below. The probability of F less S is a quarter. The probability of F intersection S is a fifth. They're given to us there. The probability of S less F is X. And the probability of F union S prime is equal to Y. So that's everything outside of that is equal to Y. X and Y are not 0. Find the value of X and the value of Y. So we use our independent events formula. The probability of F intersection F is the probability of F times the probability of S. We know this, we know this, we don't know this. So sub them in and you end up getting the probability of S is 4 over 9. So we could fill in, probability of S less F is 4 over 9 minus this. So that's X is 11 over 45. And then that means Y is 1 minus this, this, and this, which is 11 over 36. Part B. In a club, there are German, Irish, and Spanish children. There are 10 Spanish children. There are twice as many Irish children as German children. They're all in the group waiting to get on a swing. One child will be selected at random to go first and will not rejoin the group. Then a second child will be selected at random to go next. The probability that the first child selected will be German and that the second child selected will not be German is 1 over 6. How many children are in the club? Well, there's n German, there's 2n Irish, and there's 10 Spanish. So altogether we have 3n plus 10 children. The probability of, we're told that the probability of the first one being German, that's n out of 3n plus 10, and the second being not German, that leaves us with 2n plus 10 over 3n plus 9. Multiply them together, the answer will be 1 over 6. Multiply this out, you get a quadratic, and we can solve the quadratic, get n equal to 5, n equal to minus 6. Obviously, we know it's going to be a positive number because you can't have minus 6 children. So n is 5, that means 5 German, 10 Irish, 10 Spanish, 25 in total. Section B, question 7. A cattle feeding trough of uniform cross section and 2.5 meters in length is shown in figure 1. The front of the trough segment ABC is shown in figure 2. The front of the trough is a segment of a circle of radius 90 centimeters. The height of the trough is 30 centimeters. The height OA is equal to OC, is equal to OB, and is equal to 90 centimeters. So we're given this here. OB is perpendicular to AC. OB is perpendicular to AC. Find the length AD, this one here. So AD squared is equal to 90 squared minus 60 squared. We're given OD in the question there. We're given DB and we're given OB. So we take one from the other. OD is 60. So Pythagoras, get AD is 30 root 5 centimeters. Part 2, find the angle DOA, give your answer in radians, correct to 2 decimal places. So we can take the cosine of DOA, let me just get the diagram in here. So cosine of DOA is equal to 60 over 90. So cos inverse of 60 over 90 will be the angle DOA, which is 0.84 radians. Find the area of the segment ABC, give your answer in meters squared, square meters. So the area of the segment is the sector minus the triangle, so the full sector minus the triangle. So the sector is a half r squared theta, and the triangle is a half ACOD. Sub in everything that we know. We know all the the radius, the angle, we know AC, we know OD, sub it all in, you end up with 0.28 square meters. Find the volume of the trough then, answer in meters cubed, so volume is just going to be 0.28 by the length 2.5 to get 0.7 cubic meters. Part B, a sand timer for games is shown in the diagram. Each half of the timer consists of a hemisphere, a cylinder and a cone. Cylinder is height 3.5, cone is height 1.5, and all the parts have radius of 1.25. Everything is in centimeters. The upper half of the timer is full of sand. Find the volume of sand in the upper half of the timer, correct to 2 decimal places. So volume is simply going to be volume of the hemisphere plus the volume of the cylinder plus the volume of the cone. All these 3 formulas are in your log tables. Sub in the relevant values given, and you get volume is equal to 23.73 centimeters. Sand flows from the top half of the timer to the bottom part. As it flows, the top surfaces in both parts remain level, so this is just to make it easier for us. At a certain time, 98% of the sand has flowed into the bottom half of the timer. Find H, the height of the remaining sand in the conical part of the top of the timer. Give your answer in centimeters, correct to 2 decimal places. So we have 98% gone, that means we have 2% left. So 23.73 times 0.02 is that much there. That's how much sand is left. Then or over H, we basically use triangles here. So or over H is 1.25 over 5, so 5 over 6. We can write or in terms of H, or is 5H over 6. So the volume then is a third pi r squared H for a cone. We're subbing in our or, which is, we said was 5H over 6, and let it equal to 0.4746 from up here, and work it out. You get H is equal to 0.87 centimeters. Question 8. A motoring magazine collected data on cars on a particular stretch of road. Certain details on 800 cars were recorded. The ages of the 800 cars were recorded. 174 of them were new, less than a year. Find a 95% confidence interval for the proportion of new cars on this road. Give your answer correct to 4 significant figures. So we set up our confidence interval here. 0.2175 plus 1.96 is equal to 174 over 800 times 174 over 800 all over 800. So we'll have plus or minus, minus on one side, plus on the other side, to end up with 0.01889 less than P less than 0.2461. Part 2, the data on the speeds is normally distributed with an average speed of 87.3 kilometers per hour and a standard deviation of 12 kilometers per hour. What's the proportion of cars that's on this stretch of road that you would expect to find traveling at over 95 kilometers per hour? So we do the Z score for this, x minus x power over sigma, 95 minus 87.3 over 12 to get 0.64167. So the probability that Z is less than this number is 0.7389. The probability that Z is greater than 0.64167 is 1 minus this to get 0.2611 or 26.11%. Any questions again, especially with this one, question 8, just ask in the comments below and I'll clarify it if I can. Part 3, the driver of a car was told that 70% of all speeds recorded were higher than his speed. Find the speed at which this driver was recorded. Give your answer correct to the nearest whole number. So he was told that 70% of speeds recorded were higher than his. So the Z score for 70% is minus 0.52. So let's use the formula again, x minus x bar over sigma. We know 87.3, we know this, we know sigma, so solve for x, you get 81 kilometers per hour. Part B, a road safety program was carried out in the area using posters, signs and radio slots. After the program, the motoring magazine recorded the speeds of 100 passing cars. The magazine carried out a hypothesis test at the 5% level of significance to determine whether the average speed had changed. The p-value of the test was 0.024. What can the magazine conclude based on this p-value? Give a reason for your answer. The conclusion is that the average speed has changed because the p-value is less than 0.05. If the magazine found that the average speed of this sample was lower than the previously established average speed of 87.3 kilometers per hour, find the average speed of the cars in this sample correct to one decimal place. So our 0.024 from here is equal to 2 times 1 minus the probability that z is less than or equal to t. So the probability that z is less than or equal to t is 0.988, 98.8%. Our z score then is 2.6 or minus 2.6. As it is a reduced mean, we have minus 2.6. So we use that minus 2.6 as our z score, x minus x bar over sigma, to get x is 84.6 kilometers per hour. Okay, question 9. The diagram below shows a triangular patch of ground, SGH, where SH is 58 meters, GH is 30 meters, and the angle GHS is 68 degrees. The circle is a helicopter pad. It is the incircle of the triangle SGH. So find SG, give your answer in meters, correct to one decimal place. This is just a cosine rule, so SG squared is equal to this. Fill in everything that you know. S of SG is going to be 54.4, and that's meters. Find the angle HSG, give your answer in degrees, correct to two decimal places. Use a sine rule here. This is the angle we're looking for. It works out to be 30.75 degrees. Find the area of the triangle SGH, give your answer in square meters, correct to two decimal places. Area formula, half AB sine C, fill in your values, 806.65 square meters. Find the area of HSP in terms of OR, where OR is the radius of the helicopter pad. So the triangle HSP is going to be half 58 times the radius, so half the base by the height, 29 OR. Show that the area SGH in terms of OR can be written as 71.2 OR square meters. So half times 30 times OR plus half times 54.4 times OR plus half times 58 OR. All of them work out to give you 71.2 OR. So that's the area of triangle SGH, which we can split up into three smaller triangles. Find the value of OR, give your answer in meters, correct to one decimal place. So 71.2 OR from this part is equal to 806.62 from part C, or 0.65 rather should be from part C, and just work out OR to be 11.3 meters. And then the last part, ST is a vertical pole at the point S. The angle of elevation of the top of the pole from the point P is 14 degrees. Find the height of the pole, give your answer in meters, correct to one decimal place. So tan of 14 is TS over PS. So here's the angle of 14, TS over PS. The sine of 15.375 is equal to 11.3 over PS, which is 42.51. That means PS is 42.619. So now we can sub in tan 14 is TS over PS. We've just found PS. Isolate TS and solve to get 10.6 meters. Okay, so if you have any questions about this paper, just ask them in the comments below. If you want to see the detailed solutions where I go through each one step by step, I'll have a link to that video in the description and in the comments. And once I have it done, I'll try to have it done in the next couple of weeks. Thanks for watching, and I'll see you in the next video.